A little more in-depth information about the LED light emitting diode that we looked at previously in our output devices section. As you can see, I have an LED, red LED, connected by itself to a DC supply at currently 2 volts. Now, what I did mention last time is the LED is a low current, low power output device. So it would stand to reason that if you apply too large a current through it, it will get permanently damaged. So I'm going to do that. We're sitting at 2 volts. Increase to 4, still lit. Increase to 6, clearly drawn an increase in current, and it just faded and it's broken. So I'll switch that off. Oh, we've got a life left. Nope, gone. Now, you will rarely see, if at all, LEDs connected in electrical circuits on their own. Even yesterday with this old style piece of plastic has an LED, but also has this component connected beside it, which is a resistor. Now, as you know from previous circuits, you add a resistor into a series circuit, you increase the resistance of that circuit, and therefore you decrease the current. And the resistor is there, and it's what's called a protective resistor. Now, over to my, or your left, I have another circuit. The component parts are extremely small. Protective resistor, which is there, LED, which is there. I've got an ammeter just to measure the current, and I've got a voltmeter set to 12 volts. Now, in the previous circuit, with no protective resistor connected, 6 volts was enough, could have been 5, to break the LED. So hopefully, when I switch it on, it lights. Now you might be able to see ammeter reading 22, approximately 23, but only 23 milliamperes, so it's a very, very low current. Now, one other aspect which I want to do very quickly is remove the ammeter. So let's go in. Hopefully this will still light, and it still does. There's a loose connection somewhere, but it's still lit. Now, you'll be asked to do tutorial questions on the LED, but not only the LED, but its protective resistor. Now, it's crucial that you remember what happens with voltages in a series circuit. Now, currently, the supply is registering 12.5 volts. Now, clearly, the LED does not have a 12.5 volt potential difference across it, or else it would be broken. It won't even be 6. So I'm going to measure what it is. Also, quickly, in on one side and in the other. And this thing would work. It's only 1.74. The kind of typical LEDs, or certainly ones we use at the school, are 1.8 volts and about 25 milliamperes. So that's the measurements we're getting approximately. But it's important to appreciate the supply is running at 12.5. The LED potential difference voltage across the LED is only 1.7. The remaining voltage will be across the resistor, which it is, or thereabouts.